Thanks for joining us for this episode. We're going to be talking today about the TCP/IP as well as the OSI model. I don't know how depth we're going to get into it. I know we're going to compare the two, but how deep are we going to go on these topics?
Well, not really too deep because, in past episodes, one of the things that we did is, we kind of established what OSI is, the Open Systems Interconnection Model that was, done in 1984. The 126 countries came together and said, hey, let's start trying to figure out some standards and make a conceptual framework for network communications. Sometimes some people think that the OSI model came first, but that's not actually true. So if you look at 1984, when they started to standardize network communications so that dissimilar systems can communicate, interoperate, the TCP/IP model was actually called the DoD model first, and it goes back to the 70s. ARPANET, I think ARPANET came online in 1972. So it kind of gives you, and ARPANET was the predecessor to what we now have, the internet. 1998, Bill Clinton, basically they brought another military network on and they gave the internet, what was ARPANET, over to the public, right? But that internet standard has been around since the 70s, and we call it TCP/IP. Now, I think that if you are taking any kind of network exam, or if maybe you're a technician that's working on like a break-fix technician and you want to go into more networking, that's very good for your career. And one thing that's very good is to know the comparisons of these conceptual frameworks. Now, the reason I say that is because if I tell you it's a layer 3 issue, a lot of times we are talking about layer 3 of the OSI model, and more specifically the networking layer, right? We're saying, okay, that's an IP address or a routing problem. But if I say layer 3 of the TCP/IP model, well, they don't necessarily match up. So that's why I want to just take just a brief time here with Sophia, and we just kind of want to compare the differences between something that we know is the Open Systems Interconnection Model and then something that we have today largely that it's optimized and has been optimized for a very long time for communications, routable communications over the internet, and that's TCP/IP.
So I know these models are like ogres and onions in that they have layers. But there's a difference. I think one has more layers than the other. So what are some of the structural differences between these models?
Okay, so one of the things that comes off, to mind right away there, Sophia, is that we have 7 layers versus 4 layers, right? Structurally, they are a little bit different, and it's really based on what they're focused on, right? You'll see that the TCP/IP model, again, very, very focused approach. It's focused around two of the most common, the main core protocols are transmission control protocol, reliable delivery, and IP, the internet protocol, which is really how we get our information to the destination, right? But even though it just says TCP/IP, it's not made up of just those protocols. Those are the core protocols, but there are a lot of other ones. But the big thing to keep in mind is that the TCP/IP model is more a practical approach on how you can implement it in the real world, and more specifically with that being routable communications across the internet. The OSI model, though, on another hand, it is a conceptual framework, but it is a more genericized conceptual framework. And what it does is it kind of generalizes network communications. And it doesn't matter if you're talking about routing over the internet, right? It could be an inside LAN communication that never goes over the internet, right? It's going to define that as much as it will things like WAN traffic, but it's not highly optimized. So structural differences. Now, you kind of talk about it, let's go ahead and show you. I've talked a lot about it. Remember that when we talk about something like the OSI model, we are talking about, a 7-layer model starting from the top of the stack, layer 7, application, presentation, session, transport at layer 4, and then we have the network layer, layer 3, data link layer, and the physical layer, right? So there's our 7 layers, right? We're going to talk about this. I have a feeling Sophia's going to, we'll be talking about what these layers actually mean here. But application layer, layer 4. Now, notice if I say layer 4, and I put these in here in the frame so that you could see them, notice that layer 4 for the OSI model and what you can see right now in layer 4 for the TCP/IP model are not really the same. Layer 4 of the OSI model is the transport layer. Layer 4 of the TCP/IP model is actually the application layer, right? So you can start to see some of the structural differences. So what I want you to know is that very thing right there. We have a 4-layer model for TCP/IP starting at the application layer, working our way down to the transport layer, and then finally the internet layer. And we'll talk about how that compares back to the OSI here in a second. And then finally, we got the network interface layer, right? So down here at the network interface layer, remember this is where we have link establishment, things like carrier sense multiple access, collision detection, and the other one, collision avoidance if you're in wireless networks, right? Access control, MAC addresses. We're talking about the electrical mechanics of the network as well. We're talking about the bits, the encoding processes that happen to send your digital data over the electrical media. But without getting too much into the weeds with these individual layers, those are some of the structural differences that I would be aware of, especially if you're going to be sitting in an exam or if you're trying to get into networking in general.
It seems like the TCP IP model is something that would actually be adopted in network communication systems, and the OSI models may be better for if you're trying to get an understanding of how these layers interact.
Most definitely. Let me tell you where we, a lot of times, because there's a big debate. In fact, Anthony and I were talking about this big debate about taking the OSI model completely out of any network training. Because some people see it as obsolete today because of that very fact. It's theoretical. It's more of a conceptual framework. But I know right now, I don't follow that approach. I think that is the farthest from what you should ever do. You should never throw out the OSI model. You should memorize it, because if I was to come to Sophia right now and I was to say, Sophia, on our network, we have a layer 3 issue right now, she would know that that is an IP, whatever it is, IP addressing or routing. It's in the router somewhere. But if I say, Sophia, I think that's a physical layer problem, she's going to say, oh, let's go look for a link light and a connection that's broke or a connection that's not plugged in. So I don't agree with ever getting rid of the OSI model in training or in your career, because that OSI model is perfect for understanding troubleshooting. So in that aspect, I would say, yes, it is theoretical, but it's very good for troubleshooting. More practical application, though, when it comes to the TCP IP model.
Yeah, no kidding. And I saw that on your diagram, you had all of the layers of the TCP IP model laid out, and then you kind of had the layers of the OSI model connected. So are we going to actually compare the layers themselves?
Yeah, absolutely. So let me kind of go back up to the stack here while we're talking about that. Yeah, because there's certain functionality that's built in. And let me kind of zoom out here. I know we're kind of zoomed in, but at the end of the day, remember what we need. We have 2 endpoints. We need to get communication across these networks from the source to the destination, right? Both models will give you the framework to do that. However, how that functionality is grouped together is a lot different. So when we talk about the application support block in the OSI model, those are the first 3 layers. You can remember it real easy with looking at the first letter of the first 7, 6, and 5, right? Apps, it's right there. Application, presentation, and session. Just take the first letters of each word. That whole block is really what's handled in software development. We pick what protocols, the application layer we want. We pick what kind of format, the syntax layer. Do we need encryption? Are we using things like JPEGs? What's the image format, right? Session layer. Now we got to figure out what kind of session do we need? Do we need to establish a session, maintain a session? And then as we move into the network, do we need reliable delivery? All of that is typically controlled by the programmer, right? Past that, once we get into the transport layer, you don't program really anything. The network protocols are there. They take over and they move your information where it needs to go. Now, I say that to say this, because if you look at the application support block of the OSI model, the entire block is built into the application layer of the TCP IP model. All right, so let's go ahead, and I know these the icons might not make sense, but let's go ahead and just do a real quick recap. Remember your application layer protocols like DNS, email, HTTP, NFS, right? All of these type of protocols that are application layer protocols, right? But then we get to the presentation layer, and that's where we have things like ping and JPEG and GIF, GIF. I don't know if I'm going to win a bet on how it's pronounced or anything, but our compression and encryption. Now, session layer, right, is all built into that upper layer of the TCP IP model, because now we have to things like we have to handshake before we set up the session. We have to have the timing of the session. We have to have the flag markers, the synchronization, the stop-start bits, right? So we know when the session is supposed to start, how it's to be maintained, what's supposed to go over it, and then how is it going to be terminated, so that those resources can be freed up and given back to whatever the system is that we're connecting to. All of that is built right into the application layer. So go ahead. Yeah, absolutely.
So when you're looking at, I guess it's good to see it laid out visually, because I would look at the OSI model and see that layer 7 is application, and I'd be like, okay, layer 7 and then layer 4 in the TCP IP model, only thing that matches, and it would look to me like, well, what happens to layers 5 and 6? But it's all lumped into that first layer.
That's it, and that's why it's a little bit more practical. They didn't get so specific that you have to, all of that functionality is right in there, because if you think about it, again, with your APIs and your software developers, that's really what they control.
Yeah.
Past that, it's handed over to the network, and it's more like the mail carrier system handles it from there. So I wanted to go ahead, and it was a great question, just to kind of set base, just touch base with that application layer, because that's the one, like Sophia says, really kind of confuses you. You're like, wow, all of that functionality is built into that single layer, and the answer is correct. That's correct. So I want to go back to the numbering here too. If you happen to be sitting in a well-lit room answering some questions in front of a computer screen, you will have to know that layer 7 and layer 4 are the top layers of OSI and TCP IP. They have the same name, but they don't have the same layer number. So just keep that in mind. Then we go down to the transport layer, and here's where things kind of start to, they start to work well together, right? The transport layer functionality is the same in the OSI model as it is in the TCP IP model, right? This is where we get the, end-to-end communication as far as that reliable delivery. We're going to pick transmission control protocol, or we're going to say, you know what, the application, the software developers, they've got the reliability. We're going to use UDP because it's faster and it's more streamlined approach. And they build all of that reliability into the application layer. But the transport layer is also responsible for, hey, you were supposed to send me segment 53. I got segment 52. Or no, that would actually be right. That would be sequential numbers. I was expecting 53, and you sent me a duplicate of 52, right? I need you to I'm just going to discard that, and I'm going to call back to the source and say, hey, I need that packet back, right? So remember, transmission control protocol also rebuilds information when it is lost to make sure that it is rebuilt in the right order, and that is the the connection-oriented, reliable protocol versus the unreliable best ever delivery of the user datagram protocol. Now, as we move down these layers, well, unfortunately, they don't play nice together as far as their naming conventions, and I do apologize ahead of time, because I want you to be prepared that a layer 3 issue at the OSI model is different than a layer, or is the same as a layer 2 issue at the TCP IP model. The networking stack and the internet layer are pretty much doing the same thing, right? It's just called the internet layer because I want you to think about the standard. At the time that this was invented, we were routing over TCP IP, right? So these were a bunch of networks that were eventually would become globally, that were small hops between routers to get to those networks, right? All of that still happens at the internet layer. Network layer of the OSI model, functionality is the same. Now, when we get down to the last two layers, I've already kind of explained what these icons are, but that is the data link layer and the physical layer of the OSI model, all wrapped up into layer 1. See, at layer 1 of the TCP IP model, they didn't define the difference between a link layer or the data link layer. And if those of you that have seen the OSI model know that there's the LLC and the MAC sublayer in there, very, very kind of specific, if you will. TCP IP doesn't care. All of that's at the network interface layer. That's how we make a link establishment within a local area network. You'll notice that a lot of the other technologies in between are like WAN technologies, routing over networks. So that's it, Sophia. At the end of the day, just remember that the OSI Model 7 layer, we kind of talked about the functionality, the TCP IP models, and know their numbering, right? I would say that in an exam environment, that's going to be very important. Remember, if you're in a support environment, you can always look up the information, but you're going to be doing better at the end of the day and solving those tickets a lot faster if you've got that stuff right here.
Right, absolutely. Especially considering, like we talked about, the TCP IP model is something that is actually employed. And even though the OSI model is a little more theoretical, it's still really good to know. And I think, too, for somebody like me that maybe doesn't work as often with something like TCP IP, it's good for me to kind of visualize where all this stuff is happening and what each layer means. So thank you for walking us through both of these, Wes. It's helpful to compare these and see what their similarities are. And thank you for joining us for this episode, and we'll see you next time.